Okay, let's start with part 2 of physics question solving, NEET physics question solving. The first question is inside inside a spherical uncharged conducting shell centered at O, a point charge Q is kept such that OA equals D, the radius of the inner and outer surface of the shell is R and capital R respectively, then the potential of point B in figure is basically there is a spherical shell, spherical uncharged conducting shell. It's a conductor, but it's uncharged, and there is a center of this shell. A point charge Q is kept such that I will draw the diagram. This is a spherical shell. This is oval here, but it is spherical shell. This radius is small r. This radius is big R. And this is point B. This is the charge Q. And this point is called A. The center is O. And this point is C. Now they're asking, this is inside a spherical shell, uncharged conducting shell, that is having a center at O. A point charge Q is kept such that OA, this distance, equals T. The radius of the inner and outer surface of the shell is R and R. The potential of point B is. This is actually a very simple question based on a simple concept, a very seemingly complex question, but a very simple concept. Concept is the potential anywhere inside a shell, inside a conducting shell, is always equal to the potential at the surface of the shell. and the surface of the shell, the potential is the basic formula, V equals KQ by R. So this will be the answer. This, in case of here, we take it as not a capital Q but a small q. The final answer. Okay, then let's go to the next question. There are 3-point charges lie at vertices of an equilateral triangle. All charges have same magnitude, but for the triangle is these are the charges A, B, and C, but the charge at A is plus Q. The charge at B is also plus Q, but the charge at C is minus Q. Then the net electric force that charges B and C exert on A is, basically they're asking force here. Find the net electric force on by charges B and C on A. And the options are, basically they gave the axes as well. They're not asking us the net electric force, actually they're asking the direction of the force. So we just need to find the direction, not the force. And if you want to find the direction, then on the force they ask the net electric force that B and B and C exert on A. So in case of B, it exerts in this direction, and in case of C, it exerts in this direction. So these are the forces. When we take a resultant, it will be in this direction. So it is negative x-axis, not x-axis, negative y-axis. A very simple question. Normally, if when we ask the net force, we have to find the formula, but the options are in the options given are in the plus x direction, in the minus x direction, in the plus y direction, in the minus y direction. So solution is, the direction is is along the negative y direction. Okay, that was a very easy question. Now let's go to the next question. They gave that two equal point charges are fixed at x equals minus a and x equals plus a on the x-axis. Another point, another point charge q is placed at the origin. The change in electrical potential energy of q when it is displaced by a small distance x along the x-axis is approximately proportional to a direct question. Options are x, b x square, c x cube, and d 1 by x. Now they are asking us to find change in potential, not potential but potential energy. The diagram is this is the diagram. The change in electrical potential energy of q when it is displaced by a small distance x along the x-axis. So the second position is when q is displaced along somewhere in the x direction. It will be this side. Let's assume the q charge was moved this direction, then it will be a plus x and a minus x. The potential energy formula is K, the sum of all individual potential energies, by, this is the initial potential energy, A plus KQQ by A, which is U initial equals 2KQQ by A. This is the initial potential energy. Now the final potential energy equals K Q by KQQ by A plus X plus KQQ by A minus X. We can take K, capital Q and small q common. So U final is KQQ by 1 plus A plus X plus 1 minus A minus X, 1 by A minus X. And they're asking us the displacement here. Not displacement, they gave that it was a small displacement. That is the reason the charge is inside the boundaries of the two q's, displaced by a small distance. So delta U equals U final minus U initial. U final is this one, and we can directly take KQ and Q common. It is 2 minus 1 by A plus X plus 1 by A minus X, 2 by A actually, and let's take LCM here. 2 by A minus X plus A plus X by A square minus X square. When X is negligible, we neglect X. Here X will cancel. So it will be 2 minus 2 by A minus 2A by A square. Wait. When the displacement is too small, I guess we cannot do that. Let's not take negligible here, otherwise it will get directly 0, and we don't have an option of 0. So let's not neglect it here. A square minus X square. These get cancelled. It will be 2 by A minus 2A by A square minus X square. Now again we multiply here. Again we take LCM here. It will be 2A square minus X square minus 2A square by A cube minus AX square this times KQQ by KQQ by 1. This is a change in potential energy. Now again let's multiply it inside. K cube q by 2a square minus 2x square minus 2a square. A square get cancelled. The total change in potential energy will be minus kqq x square by a cube minus ax square. Since we know that it was a small displacement, a is much greater than x. Now we neglect x, 0. And now if we see, the final potential energy formula is 2kqqx square by a cube. Here if we see, potential energy, change in potential energy is directly proportional to x square. So the final answer and option B is the correct answer. Okay. Now next question is, an electron falls through a small distance in a uniform electric field of magnitude 2 into 10 power 4 Newton per Coulomb. The direction of the field is reversed. Keeping the magnitude same. And a proton falls through the same distance. The time of fall will be options are same in both cases. B, more in case of electron. More in case of proton. D, independent of charge. Okay. An electron falls through, let's read the question. An electron falls through a small distance in a uniform electric field of magnitude 2.10 2 into 10 power 4 Newton per. In this kind of cases, the magnitude is kind of useless here. The direction of the field is reversed, keeping the magnitude same, and a proton falls to the same distance. The time of fall will be, there is a magnetic field here, not magnetic, an electric field. When this was the field, an electron falls this much distance, and when we reverse the electric field, a proton also falls the same distance, then which will be faster? They're asking which will be faster. Wait, I think I showed the direction. So this is the question, which will be faster, or if it will be same for the both. It is of course not independent of charge. This is option D is not correct. Basically, this answer depends on a equation here, that is D equals half of QE by M T square. This is basically derived from, we know that D by T square will become acceleration, and half of QE is force by mass. So it is force equals mass into acceleration, but there is a half here. Okay, it is similar to that. Now here, this is an equation, but it might be related to force into distance, which is equal to work, which is equal to change in kinetic energy, which is half mv square. Force into distance. Now when we want to find distance equals half of mv square by force. But there is no time here, but basically that is the formula, and based on this formula we do not want to find the distance, but we want to find the time taken. So time equals t square equals 2dm by qe, and t equals root of 2dm by qe. From this equation we know that t is proportional to time, or t square is not proportional, t square is proportional to mass. So higher the mass, higher the time taken. So in that case, since proton has higher mass, proton should take higher time than electron. So it should be more in case of a proton. Okay, let's go to the next question. A charged particle of charge q and mass m is released from rest in a uniform motion not uniform motion, but a uniform electric field. E, neglecting the effect of gravity, the kinetic energy of the charged particle after time t is. They're asking a charged particle of q and mass m is released from rest into a uniform electric field, neglecting the effect of gravity, the kinetic energy of the charged particle after time t is. Okay. Solution, they're asking kinetic energy equals, maybe you should use the force formula. Change in kinetic energy equals work done, so equals force into displacement, where force equals QE times T. But since we need to include T, okay, force times displacement, and based on Newton's laws, not Newton's laws, I mean formulas of motion, S equals ut plus half at square. This is same as this. Instead of S, we can write it as D here, since they gave clearly that it is from rest. Initial velocity is 0, so D equals half at square. So change in kinetic energy equals QE half at square, and we can write acceleration as force by mass. Acceleration equals force by mass, and we can write force as QE by m. So we can substitute in this equation. Kinetic energy equals QE by half QE t square by m. So it is equal to half q square e square t square by m, or we can write it as q square e square t square by 2m. Why we are going all through this headache to find an equation for change in kinetic energy is because this is the only option given in the this is the only correct formula given in the options, so this will be the final answer. Okay, then let's go to the next question. If there is a uniform electric field in x direction if the work done by external agent in moving a charge of 0.2 coulomb through a distance of 2 meter slowly, meaning with uniform velocity or speed along the line and no acceleration, making an angle of 60 degree with x direction is 4 joule. The work done is 4 joule. Then magnitude of electric field is, okay, there is a uniform electric field in x direction if work done by external agent against moving a charge of 0.2 coulomb through a distance of 2 meters slowly along the line, making an angle of 60 degree with the x direction is 4 joule. Then magnitude of E is, this is the direction of electric field, and when we are going, this is the 60 degrees, this is the path followed by the 0.2 coulomb charge. Work done here is 4 joule. Now the distance is 2 meter, and work done equals FD cos theta. Work done equals, from this formula we know that force by Q equals electric field and QE equals force. So 0.2 times electric field times distance of 2 times cos 60, which is 1 by 2, 2 cancel. Work done is 4 joule, and it is 0.2, 4 by 0.2 is equals to electric field, and electric field is 40 by 2, which is 20 Newton per coulomb. Final answer is 20 Newton per coulomb. Let's go to the next question. A point charge Q is situated at a distance d from one end of a thin non-conducting rod of length L having a charge Q uniformly distributed along its length, then magnitude of electric force between them is. Okay, there is a point charge q situated at a distance d from one end of a thin non-conducting rod of length L having a charge q that is uniformly distributed along its length, then magnitude of electric force between them. There is a rod like this. This is a non-conducting rod, and there is a charge here, that is q. The length of the rod is L, and the distance between the charge and one end of the rod is d. Then they are asking the electric magnitude of electric force between them. So since this is uniformly distributed, that is one of the main criteria, and taking a small length element dx, the total, and a small charge element dq, the total force equals kq q by r square. Let's take it as capital Q, and since we are taking a small force element, it is df, which is equals to kq dq by r square. Now we do integration here, integrate it. Df equals dkq dq by r square, which is equals to force equals kq by dq by r square, because the outside charge is constant. Or we can take in another way, that is df equals kq dq by x square, and this is, and the total charge here is q, so let's not take it as capital Q here. Let's take it as small q itself. This is a capital Q here, and from linear charge density formula we know that we can write charge as dq by L, which is equals to linear charge density, or we can write dq as total charge by length times unit distance or small element L, as both are same. So we substitute df equals kq by L times d of x by x square. Now we do integration d of f, which is equals to limits, which is from the distance, plus d plus L k q by Lx square d of x. Here everything except x is constant, so df f equals 1 by 4 pi epsilon naught, which is k value, q by d times of d plus L. This is the final value after integration. Okay, then let's go to the next question. They showed a charges diagram here where this is the y-axis and this is the x-axis. X-axis here, there's a charge of plus 16q here, and this position is 2a, x equals 2a, and there is a charge of plus 25q here. It is position is x equals 20a, so the distance between them is 18a. Now they're asking where should a third charge particle be placed so q naught, the third charge particle, that is q naught particle, be placed so that this q naught will be at equilibrium, where the net force will be 0. Okay, this is what they're asking, where in between them, where we should place so that the q naught charge will be at equilibrium. So basically the clue here is it should be at equilibrium, so meaning net force on it should be 0. Net force on q naught should be 0 if in equilibrium. So force on q naught due to 2a charge, which is equals to, is a position of the, let's name it as charge A and charge B. So this is not q naught times 2a, but q naught, the force on q naught due to A, which is equals to k q naught times 16q by, let's assume it should be placed somewhere here where a distance is x and this whole distance is 18a minus x at x, and fq naught due to b is kq naught I mean not 16 but 25q by 18a minus x, both are equal. So q naught 16q by 18a, wait, x, which is equals to q naught 25q by 18a minus x. Here q cancel, q naught cancel, where only 16 by, even k also was there, which I cancelled. 16 by x, which is equals to 25 by 18a minus q. Since you want to find x, let's shift them both that side. 18a minus x times 16, which is equals to 25x, and 18 times 16, which is 288, is 288a minus 16x, which is equals to 25x. So 25 plus 16 is 41. X, which is equals to 288a. So x equals 288 by 41, which is, I think, should come to be around 8a. 41 into 8, which is equals to 8 4 24, 248. Okay, x should come to be around 8a. So the total position should be at 8a plus 2a, that is 10a. I will see this question later again, but let's go to the next question. Okay, we got a wrong answer because I forgot about squares here. There should be a square here. Square. So there should also be a square here as well. And from here on out, it is better to write the formula. This is correct, but okay. From here on out, to solve this question, it is better to take square root on both sides. So it will be root 16 by x square, which is equals to root of 25 by 18a minus x whole square. We can write it as 4 by x, which is equals to 5 by 18a minus x square. Wait, not x square, just x. It will be 4 times 18a minus x, which is equals to 5x, which will be 72. 72a minus x equals 5x. 6x equals 72a. Now this will lead to this. Wait. Here there is a 4 here, not. It will be 9 here. So this will lead to 8a to be the answer. Now the next question is, there are 3 concentric shells, spherical shells of radius r, 2r, and 3r, and are given charges q1, q2, and q3 respectively. It is found that the surface charge densities on the outer surfaces of the shells are equal, then the ratio of the charges given to the shells q1 is to q2 is to q3 is. There's a question. There are concentric shells of radii r, 2r, and 3r and are given charges q1, q2, and q3 respectively. It is found that surface charge densities on the outer surface of the shells are equal and the ratio of four of the charges will be. Solution, I think this is based on the surface charge density sigma. Sigma equals q by area, which is in case of a spherical shell, it is 4 pi r square. So sigma 1, which is equals to q1 by, no, sigma is given to be equal, so it is q1 by 4 pi r square. Sigma equals q2 by 4 pi times 4r square, and sigma equals q3 by 4 pi 9r cube, not r cube but r square. Now in this case, let's take a ratio of all of them. q1 by 4 pi r square is to q2 by 4 pi, let's take it as 4 pi, wait, we do not need to take ratio of their surface charge densities because they are equal. We need to take ratio of their charges. So sigma equals q1 equals sigma 4 pi r square and q2 equals sigma 4 pi q2 equals sigma 4 pi 4 r square, and q3 equals sigma 4 pi 9 r square. Now we take all the common things, delete, it will be all sigma is cancelled, all 4 pi is cancelled, r square is cancelled, 1 is to 4 is to 9. But that doesn't seem to be the case because we are taking even induction here, induction into consideration. So when we take induction into consideration, we will need to take sigma 1 equals sigma 2 equals sigma 3, when if, let's assume, third is the largest cell with having 3r radius. Now it should be the case that q1 by 4 pi r square, which should be equal to q1 plus q2. This q1 charge is due to induction from the inner shell. q1 plus q2 by 4 pi 4r square, which is equals to q1 plus q2 plus q3 by 4 pi into 9r square. Now if we cancel them out, we will get 4 pi r square, 4 pi r square, which is equals to, we will get q1 equals q1 plus q2 by 4, and q1 plus q2 plus q3 by 9. And from first this relation, q1 4q1 minus q1 equals q2, so 3q1 which is equals to q2, and from this one we will get q1 equals q1 plus 3q1 plus q3 by 9, so it will be 9q1 which is equals to 4q1 plus q3, so 5q1 which is equals to q3. From this we will get that the ratio between q1 is to q2 is to q3, which is equals to 1 is to 3 is to 5. This is due to induction when induction is applied. Now let's go to the next question. Two spheres of radius r and 2r rest wait now yes having charges q and 2q respectively are placed far away from each other, how much charge will flow when when a wire is connected? They're asking how much charge will flow when a wire is connected when two spheres of radius r and q and one more sphere of radius 2r and 2q charge. There will only be flow of charger if the potential is not zero. So let's calculate the potential difference. Potential due to charge, I mean sphere A here and sphere B, VA equals K Q by R, and VB equals K2Q by 2R, so equals to KQ by R. And when we take potential difference, there should be a potential difference, then only the charge can flow. VB minus VA is equals to KQ by R minus KQ by R. So the potential difference is zero, so no charge will flow because potential difference is zero. Let's go to the next question. A charge of 8 microcoulomb, 8 millicoulomb is located, milli meaning 10 power minus 3, at the origin Calculate the work done in taking a small charge -2 into 10 power -8 coulomb from a point P 0, 0, 3 centimeter to a point Q 0, 4, 0 via a point R 0, 6, 9 centimeters. They're asking if a charge 8 millicoulomb is located at the origin. Calculate the work done in taking a small charge -2 into 10 power -8 from a point P 0, 0, 3, 0, 0, 3 and 0, 4, 0 from P to Q first, that is via a point 6, 9. It is better to consider uh, only one kind of, like two kind of axis here, because they did not provide a value for x-axis. So let's only consider the z and y-axis here. First, there is a charge at the origin which is 8 microcoulomb. There is a charge -2 it is -2 millicoulomb. Not -2 millicoulomb, it is -20 nanocoulomb, but 2 into 10 power -8 coulomb from 0, let's take it as 0, 3 itself. This is the z and y axis. From point here to point here, which is 4, 0 via point 9, 6, which is not going to be here but here, which is 9, 6. The distance from here to here and then here to here. Okay, it's better to draw the diagram a little more clear. Here, from here to here, 9, 6. And we know the formula. Work done equals Q delta V and microcoulomb charge at there. And I don't think we need to consider this point here. We only need 2 points, that is these 2 points. The initial is here, final is here. The path doesn't matter. So W equals -2 into 10 power -8 coulomb times initial minus final minus initial potential, that is K 8 millicoulomb of charge, 10 power minus 3 by the distance from origin is 4 centimeter, 4 into 10 power minus 2 minus k of 8 into 10 power minus 3 by the distance here is 3 into 10 power minus 2. So finally the answer will get work done equals minus 2 into 10 power minus 8 by 10 power minus 3 we can take common, 10 power minus 3 into k also we can take common, which is 9 into 10 power 9. 8 as well we can take common into 8 by 10 power minus 2 as well we can take common. 1 by 4 minus 1 by 3, this will be equal to 8 into minus 2 into 9 into 10 power minus 8 times minus 3 into 10 power 9 into 10 power plus 2, which is 8 into minus 2 into 9 into 10 power minus 11 into 10 power plus 11 by 3 minus 4 by 12, which is minus 8 into 2 into 9 into minus 1 by 12 minus minus plus 2 ones are 6 are 3s are 2s are 3s are 1s are 4s are. So work done finally is 4 into 3, which is 12 joule. The initial via this point is basically just for a confusion, is the only formula we need to know here is this formula and the potential formula. Okay, let's go to the next question. Now the question is, a proton is projected with a velocity v towards another free proton at rest from distant point from infinity, then the distance of closest approach will be. Now they're saying here there is a proton, there is another proton here that is not fixed, there is a free proton, a very important point to be remembered. A free proton, this is having a velocity v, the closest distance that it can come to before this proton starts moving away and this proton's velocity stops is d. This d, how we should find out, they're asking. Okay, this is based on conservation of linear momentum and conservation of mechanical energy. So before, at infinitely distance far away and at some distance, at this is, let's assume this distance is infinity, and at one point this became v1 and this became another v2, and this is the distance, minimum distance. Now based on this, at initially and finally, like the momentum should be same, so it should be mv, which is equals to mv plus mass into zero velocity, the other one was 0, is equals to mass into v1 plus mass into v2. So mv equals v1 plus v2. So velocity equals v1 plus v2. This is one of the relations we got. It seems that these both should also be equal. So v equals v1, v by 2 equals v1. So based on relation, work energy theorem, that is delta change in kinetic energy, which is equals to work done and force into distance equals work done. Force into, we can write as d minimum, that is the point we are getting it to, which is equals to ke final minus ke initial, which will be half m v by 2 whole square minus half m v square and force equals, according to Coulomb's law, it is k e times e, which is e square by d minimum. But then d minimum should get cancelled, but that should not be the case. Yes, okay. This is d minimum whole square. I keep forgetting this. I should always write the Coulomb's law formula. It is d square, so it is d minimum. Then this we can write as 1 by m v square, which is equals to ke square by d minimum. Wait. This is 1 by 8 mv square minus 1 by 2 mv square. The answer is coming in negative, but let's see. 1 by 8 mv square minus 4 mv square and kinetic energy, something I missed, something more I missed here, that is something more I missed, that is here here the final should be times 2 because there are 2 electrons here, so it should be times 2. So it will be 2 half m v by 2 whole square. It will be half cancelled, so m v square by 4 minus half mv square, and there is also k here. But we are getting negative value. If we do, it will be mv square minus 2 mv square by 4 ke square by d minimum should be minus mv square by 4, which is equals to ke square by d minimum, and d minimum value will be equal to 4 ke square by mass times velocity. There should be a minus here, but I don't think we should take minus in this case because it is displacement. This will be the final answer. 4k square by m v square here. I forgot to write the mv square. Okay, this will be the final answer. If it was a fixed proton, that would have been a little bit easier, but fine. Now let's go to the next question, that is a thin conducting a thin spherical conducting shell of radius r has a charge q. Another charge q is placed at center of the shell. The electrostatic potential at a point P a distance r by 2 from the center of the shell is, okay, there is a thin spherical conducting shell of radius r and it has a charge q. The total spherical shell's charge is q. There is another charge q is placed at the center of the shell. The electrostatic at potential at point P at distance r by 2 from the center of the shell is a distance of r by 2 from the center of the shell. Okay, which is kind of an easy question here. It's just a little too easy concepts. They merged and made it into a harder concept. It's always becoming an over here for me. That's better. This is a spherical shell having a charge of q and there is another charge q at the center. The radius is r at a point where this distance is r by 2. There is a charge, wait, here this is a point P, the potential at Vp, which is equals to question mark. And there are two concepts here. The first is solution. How to do it is, we know there are, first we need to first find potential due to shell and find potential due to charge and add them up, because potential is scalar. And one more concept is potential inside a shell will always be equal to the potential at surface of the shell. This is the two concepts. Now first, potential point P due to shell will be equal to K, the point Q by R, and P due to charge will be equal to K. Wait, this is not capital Q but small q, but because that is a charge of Q, charge on shell, and this will be KQ by R by 2, which is 2KQ by R. Now adding them up, we will get V at P total will be equal to 1 by 4 pi epsilon naught. First, the point due to charge, which is 2Q by R plus 1 by 4 pi epsilon naught Q by R. This is the final answer. Now let's go to the next question. That is an electric dipole placed at origin is directed along x-axis at a point P far away from the dipole is the electric field is parallel to y-axis. OP makes an angle theta with x-axis. Okay, let's read the question again. They're saying an electric dipole is placed at origin. An electric dipole is placed at the origin, that is along x-axis at a point P far away from the dipole. The electric field is parallel to the y-axis. The first information is an electric dipole placed at origin is directed along the x-axis at a point P. Okay, that is the first information. At a point P far away from the dipole, the electric field is parallel to the y-axis. Origin and point P makes an angle with theta with the x-axis. Then they are asking option A, tan theta equals root 3, tan theta equals root 2, theta equals 45 degree, D, tan theta equals 1 by root 2. Okay, so let's assume this is the origin. Directed along axis is the dipole, minus q and plus q. At somewhere at point P, the electric field is parallel to the y-axis here, and this is an angle of theta, which I will not be doing right now, but I will be doing it later. Let's go to the next question. The next question is a very easy question actually. The electric field intensity inside a charged conductor surface is it is of course 0. The electric field intensity inside a charged conductor surface will be 0. Let's go to the next question. There are two rods. Here there is 3q charge, minus 2q. Here there is x dash charge and x charge here. There is one more pole like this, or a rod like this. This is having a charge q. They are asking to find x, and x equals to how much and x dash equals to how much if they are charges where x and x dash are charges. Now let's observe here. The options given are x equals minus 2q and x dash equals 0, b x equals plus 2q and x dash equals 0, c x equals minus 2q, x dash equals plus 4q, d it is x equals minus 4q and x dash equals plus 2q. Let's go with elimination method first. Now let's go from last, where they're saying this charge developed will be positive. That will not be the case. Okay, I'll be back in a minute. Okay, then I took a longer break than expected, but let's start. I mean, let's continue. Okay. The question was, there are three rods here, each having charges of 3q minus 2q and q. And this is the middle charge. Due to induction, they're asking what are the charges x and x dash. And I was going through the elimination method first. Through elimination method first, obviously this charge and this charge both should be negative charges, almost negative charges at least, otherwise neutral completely, because this 3q is greater than q. Both should be mostly positive charges. X and x dash should be mostly positive. They should not be negative, and this should never be negative. X will never be negative, will never be lesser than 0. It will be way greater than 0. And so any option that is negative is wrong. So obviously, wait. No, I meant that both will be positive. I mean, wait. No, both will be negative, not positive. They will not be positive. I mean, they will, x will never be positive. Here, this will always be lesser than 0, because it's a very large charge and it's a negative charge. And this is q. X will always be greater than 0. I mean, lesser than 0. X will mostly be negative. X dash also will mostly be negative. So in this case, where x dash is this much positive, is not possible. So it's not option D. And there is no way the induced charge x dash can be plus 4q. That is also wrong. And from the first two options, there is no way this charge can be positive. This will mostly be negative. So option B also gone. So option A is the correct answer. And to go in the other way, that is not through elimination, okay, it is, this question is based on electric field inside a conductor will always be 0, that concept. And electric field due to an interface charge of infinite long sheet will be sigma by 2 epsilon naught. And the total charge will be 3q plus q minus 2q, which is 2q. Fine, let's solve this question more correct way next time. Let's go to the next question. Okay, the next question is, a spherical charged conductor has surface charge density sigma, the potential at the potential at center is V if the radius of this sphere is doubled keeping sigma constant, then potential at center of the sphere becomes, this is a very easy question. So here they gave that sigma 1 equals sigma 2, where r1 equals to r2. So when we compare the sigma 1 form, sigma equals q by area, or 4 pi r square for spherical shells, and q1 by 4 pi 2r2 2r2 square, which is equals to q1 by 4 pi r1 square. Now 4 pi gets cancelled. This is also r2. Wait, this is, wait a second, this is q1 and this is q2. Now it will be q1 by 4r2 square equals q2 by r2 square. R2 square get cancelled, where q1 by q2 equals 4 by 1, or q1 equals 4 q2. Based on this, we can use the potential formula. V equals kq1, wait, yes, kq1 by initial potential is kq2 by r2 whole square. Wait a second. Okay, V final will be equal to k q2 by, there was no need to, I believe there was no need to find all the surface density and charge ratio. Okay, then r2 will be doubled. Wait a second. It is better if we don't use this formula. Let's not do that. Let's go again from the start. It is better to use V equals sigma r by epsilon naught. Sigma is constant. So when let's assume V initial equals sigma by r initial by epsilon naught, and V final equals sigma by r final by epsilon naught. R final is sigma to r initial by epsilon naught. Now we want v final, so v final equals v initial, v final by v initial equals sigma 2 pi r initial by epsilon naught by sigma r initial by epsilon naught. So v final will be finally equal to 2 times of v initial. So this is the potential which is doubled. Let's go to the next question. Actually, in this way, if we wanted to go where the final and initial potential, then that we should find the q1 charge, and we should divide v final by v initial. So v final by v initial will be equal to k 4q1 by 2r whole square by kq by r, not r square. There is no r square here. This is 2, and kq by r cancel, so v final equals 2v initial. This is also a correct way, but this is a bit longer compared to this way where there is a direct formula here. Okay, let's go to the next question. Okay, this is not a electrostatics physics NEET questions chapter, but it is just NEET physics questions chapter, not chapter but solving. The one of the questions is one of easy questions itself, but the question is, which of the following function remain unchanged after differentiation or integration? This is A sin x, B tan x, C secant x, D exponential e power x. So obviously the answer is D. Okay, let's go to the next question. They gave next question is equation of a line is okay, wait a second. This is a y and x graph. This is the slope. This point is 2 comma 12, and equation of graph is y equals 3x square. This is point A. Now they're asking find slope of graph at A. Okay, the slope of a graph equals dy by dx. We can write this as equal to, which this is 6x. Okay, basically dy by dx is d3x square by dx, which we will get it as 6x. Okay, then we know x coordinate equals 2 in the line they showed here. So slope equals 6 times 2, which is equals to 12. Let's go to the next question. A metallic disc is being heated. Its area in meter square at any time t in second is given by A equals 5t square plus 4t plus 8. Find rate of change of area at t equals 3 second. This is a kind of easy differentiation question. We should find dA by dt, which is equals to d 5t square plus 4t plus 8 by dt, which we will get it as 10t plus 4, and they gave t equals 3, so 10 times 3 equals 30 plus 4, which is equals to dA by dt at 3, which is equals to 34 meter square per second. Now let's go to the next question. If acceleration, these are all easy questions. If acceleration of a body is given by A equals 6t square plus 2t, find expression for velocity. This is expression velocity given body starts from rest. We know that dv by dt equals acceleration, and to find dv we need to find a times dt. So when we integrate dv we will get integration of a with respect to dt, v equals 6t square plus 2t square plus 2t with respect to dt integration. Now v equals, we can write this as 6t square plus 2t. They gave a limit from 0 to t, 0 to v. Because the body is starting from rest, we take limits as 0 to v. V equals 6 will come outside, and differentiation of integration of xn to dx will be equal to x to the power of n plus 1 by n plus 1. So here velocity will be equal to 6 times t cube by 3, which is 2t cube, plus 2 times t will be 2t square by 2, which will be final velocity will be, we are the lower limit is 0, so we are not going to apply the limits. 2t cube plus t square is the final expression for velocity. Now let's go to the next question. They're asking, they showed a graph, not correcting. Okay. This is x, and y. This is the graph. This is the graph. They're asking, this is a they're asking what does this graph say? Does it continuously increase? No, it does not continuously increase. Continuously decrease? No, it does not continuously decrease. First increases, then decreases? No. First decreases, then increases? Correct. It first decreases, then increases. Then there is one more question. That is, they're asking value here, tan 90 plus theta times secant 180 minus theta times sine minus theta by sine of 180 minus theta cot of 360 plus theta times cosecant of 90 plus theta. This, for solving this, you need to know all the conversions here. Solve. Now we can convert tan 90 plus theta as 90 plus theta, so it will be negative since it is in the second quadrant. In the second quadrant only sine and cosecant are positive, so minus cot theta, secant 180 minus theta in the second quadrant it will be negative, so minus, wait, it is 180 minus theta, so it is minus secant theta, and sine minus theta is minus sine theta by it is sine 180 minus theta is sine theta since it is in the second quadrant, and cot 360 plus theta it's in the first quadrant, and 360 the function doesn't change, so it is cot theta by cosecant 90 plus theta in the second quadrant. 90 will change but it will remain positive, sine theta, sine theta cancel, and cot theta cancel, we'll get it as, there might have been a mistake. Tan 90 plus theta is minus cos theta, secant 180 minus theta is minus secant theta, and sine minus theta is minus sine theta, sine 180 minus theta is sine theta, and cot 360 plus theta is cot theta, cosec 90 plus theta equals, it seems this is not sine theta, it seems I have forgotten, this is not sine theta but secant theta, it is secant theta, so secant cancel, and we will get minus into minus into minus, so minus 1 is the final answer. Now let's go to the next question. Okay, next question is, find a vector having magnitude double of 3 cap plus 4 cap and direction same as 5 cap plus 12 cap. The magnitude should be same as 3 cap plus 4 cap, but direction should be 5 cap plus 12 cap. and we know the equation magnitude of A vector times A cap, which is a unit vector, will give the actual vector. And since we need a direction same as this one, we need to find the unit vector of that. And since it should have a magnitude of this one, we'll find the magnitude of that. First, let's find the magnitude of 3 cap plus 4j cap, which is basically root 3 square plus 4 square, which will give root of 25, which is equals to 5. So magnitude equals 5 units. Now to find unit vector is A cap equals, this is the unit vector, A vector by magnitude of A vector. So for magnitude of 5 plus 12, we will get it as root 5 square plus 12 square, which will get it as root of 169, which is 13. So A cap equals 5 cap plus 12j cap whole by 13, which is the unit vector. Now, based on the first equation, this equation, we write them both together, which is magnitude, required magnitude is this one, or here I wrote it. This is the required magnitude, this is the required direction. So A vector equals, or the new vector equals, magnitude is 5 times unit vector, which is 5 cap plus 12j cap by 13. This is the final answer. Now they're asking a statement based question. Which of the following statement is correct? I'll not be writing them, I'll be reading them. Angle between parallel vectors is 0. Angle between parallel vectors is obviously 0. So correct. Next is angle between anti-parallel vectors is 180 degree. This is also correct. Parallel vectors have same unit vector, and anti-parallel vectors have opposite unit vector. Here in this case, A vector, if this is a A line and this is a B line, A cap equals B cap. In case of anti-parallel vectors, if this is A and this is B, then A cap equals minus B cap. This statement is also correct. And the fourth option is all of the above. So fourth option, all of the above, is correct. Okay, they're asking one more question. It's also a kind of statement kind of question, like find the correct answer. Which of the following is not essential for 3 vectors to produce 0 resultant? Which of the following will not provide 3 vectors will not provide 0 as resultant? First one is resultant of any vector, any 2 vectors should be opposite and equal and opposite to the third vector. In this case, if these are A, B and C, if this resultant by A and B, resultant AB, if these both C equals C magnitude, C vector equals minus of RAB vector, then resultant is 0. Then total is 0. So this will produce a 0 vector. So this is not correct. Second is they should lie in the same plane. If they lie in the same plane, there will be a 0 vector. It should be possible to represent them by three sides of a triangle taken in order. If it is like this, then net is equal to 0. So this is also not correct answer. And one more option, they should act along the sides of a parallelogram. And if they act along the sides of a parallelogram, the resultant may or may not be 0. So it's option 3. And the next question is, they showcased a diagram here. Example, that is not array. This is a normal hexagon. This is a normal hexagon, and I think it would have button if I, yeah, this is much better. Okay, this is a hexagon. The center of this hexagon is O, and the sides are A, B, C, D, E, F respectively. Then they are asking value of AB vector plus AC vector plus AD vector plus AE vector plus AF vector. All are having A. When we take AB vector, it is in this direction. AC vector, it's in this direction. AD vector, it's in this direction. And AE vector, it's in this direction. And AF vector, it's in this direction. Law of polygon. And if we take it as if we take that the resultant of AD and B is, wait, Okay, since if we take AB vector and AE vector, AC vector and AE vector, AC vector plus AE vector, this is the vector sum, then we will get resultant to be AD vector, and we will get AD vector even when we take AF vector plus AB vector. So we will get, when we add these two up and these two, we will get AD vector plus AD vector plus AD vector. The final value, the value will be value equals 3 AD vector, but this was not given in the options. Since we have an AO vector here, we can write it as, we can write AD vector is equals to 2AO vector. So substitute this value here, we will get 3 times 2AO vector is equals to final value equals 6 times AO vector. Okay, let's go to the next question. A particle is moving on a circular path of radius r with uniform velocity. V, the change in velocity when the particle moves from P to Q is where angle of POQ equals 40 degree. I'll draw the diagram. This is the center. O, this is 40 degree. Velocity at P is V in this direction, and at Q is in this direction, and this is the radius. They're asking a particle is moving on a circular path of radius r with uniform velocity v. The change in velocity and the particle moves from P to Q is. The change in velocity, there's actually a formula here. There is, for change in velocity equals 2v sine theta by 2. So in this case 2 times of v sine 40 by 2, which is final change in velocity. There is no change in magnitude of velocity, but only direction. So direction is 2v sine 20 degree. This is the final answer. Now there is a statement type question, or a which of the following is correct, which of the following statements are correct kind of question. They gave statements are: 1, a vector times scalar product is a vector quantity. This is obviously wrong. This is wrong statement, because this is a scalar product and will give a scalar as the like the physical quantity. And when we take a cross b, this vector product is perpendicular to plane of a vector plus b vector. A cross b is perpendicular to the plane of a plus b vector. If we need to find, if let's draw the diagram, if there are, this is one vector, and let's assume this is one vector a and b, a and b vector. When we take a times b, then we then the direction of the quantity will be inside the screen. It will be an x using the right hand rule. It will be inside, and when we take a plus b vector, a plus b will be somewhere like this. The resultant vector will be somewhere like this. So any kind of vector in this plane will always be perpendicular. This angle will be, theta will be 90 degrees. So this statement, second statement, is correct. For two orthogonal vectors, a scalar product of b equals 0. This is the definition of orthogonal vectors, so it is indeed correct. Orthogonal vectors, vectors where the scalar product is, or the product vector product is 0. If vectors are parallel or anti-parallel, then a cross b equals 0, because a cross b is basically ab is sine theta, and if vectors are parallel like this, theta equals 0, sine 0 equals 0, and when they are anti-parallel vectors, theta equals 180. Here as well, sine 180 equals 0. So both the cases, the final product will be 0. So this is also correct statement. So the Second, third, and fourth statements are correct, whereas the first one is wrong. And the next question is, three forces are acting on a body. Three forces acting on a body. To have, there is a diagram. I will draw the diagram. Resultant force only along the y direction the magnitude of the minimum additional force needed is, the diagram is, these are the axes x and y dash. There is a vector acting like this. Vector in this direction. This is 1 Newton. Angle is 60 degree. One more acting it's not working. Fine, leave it be. One more is acting this way, 30 degrees. And this is also, this is a 4 Newton force, and one is acting this way. The angle here is also 30 degrees. This one is 2 Newton. For this resultant, for the resultant of these forces to be acting, first let's find the resultant here. These both cancel out, so the total diagram will shift from this to this force cancelled. Since this will become 2 Newton, then it will be acting somewhere not in the y-axis but somewhere like this or something like that. The minimum additional force in this side required to keep it in the y-axis only is, so according to the problem, force along the x direction will be 0. Net force along the x direction will be 0. Then the question is based on f vector equals fx cos theta I cap plus Fy sine theta j cap. Since fx cos theta is 0, will be 0. Let's add f net will be equal to fy1 plus fy2, I think. Now fy sine 60 degree this is not fy, let's take it as 1 Newton itself. 1 Newton, so plus one more force acting in the y direction is 2 times 2 Newton, 2 of 60 degree, I believe it is with the 2 of sine 60 degree. It will be 3 sine 60 degree. Sine 60 degree is root 3 by 2, I think. Wait, we should not take this as we should not take this one as sine 60 degree. We should take it as, just a minute, we should not get confused here. We should take it as 1 Newton cos 60 degree I cap plus 2 sine 30 degree I cap. Here we take 30 degree here. Okay. Then we can convert this into cos 60 degree is 1 by 2 plus 2 1 by 2, which is equals to 1. And this should actually be minus here when we are taking the net forces. So it should be 1 by 2 minus 1, which is equals to minus 1 by 2. So net force should be 0.5 Newton. Okay, that's it with the questions. In this video, I will be continuing the questions hopefully in the next